same electron beam, if the same electron beam, if it is incident in angle, then how the surface will be. Again, at various temperatures, what will happen to that beam? That was the work assigned for them. So they started doing work. So when they started here, so let me take the metal block, nickel. This was the incident beam. I'll just show electrons. How do I produce this electron gun? The electron gun. So when they saw this, so what they noticed is these electrons, what happened? They were scattered. So they were scattered. Just show like this. So this is the and the scattering angle. What they got is 50 degrees when it was accelerated by 54 volt. When the electrons open, when they're accelerated by 54 volt, they got scattered here. Now, what is this curve? There's a direction of incident beam. I'll just show it. I'll do one thing. So here there was a scale. Different books, they're given different way like this. Have patience. Let me finish off this experiment, then you'll understand. Let me finish off at least that experiment. No? So what is this? This is a galvanometer. So there's a galvanometer which can, so here, how is the galvanometer? It was having a tray where the electrons, what happen, will come and strike that tray. And there's a galvanometer. And there's a scale, and it will be metal scale you can trace, and it is earthed. Then no, because the current has to flow, no? The electrons, and these are the blue color is what? So this one, I'll explain that one. So now what happened is the electrons which are incident, no, they got scattered. And they saw that most of the electrons, what happened, they had a scattering angle. Some electrons, happened, they had a scattering angle more than 50, some they're less than 50, and their number. And most of the electrons, they got scattered by an angle 50 degrees. If say electron, if it were only particle, then what do you expect? They'll come, collide, and all should have one specific angle. They should get deviated, no? But some they got deviation more than 50, and some they got deviation less than 50. So what is this? Like what is this length? This length will show the number of electrons. I am showing red color laser dot. You try to see what this width it will show. The number of electrons. Most of the electrons happen, they got scattered by an angle 50 degrees. And there are some electrons what happen whose scattering angle is less than 50 what happen got decreased here. And there are some, and so there are some electrons what happen where the scattering angle is less than 50 degrees. And most of the electrons So this one. So now this peak is something very important for us. And how do I can say detect, how do I can detect that one? So what I do is like, I'll just move this galvanometer. There's a metal scale. There's a scale. I'll move this galvanometer where I can measure this angle. It'll be oriented. So as I move like this, as I move like this, so then the deflection galvanometer will be maximum when it comes to this position. Say I don't see this blue color in lab. I don't see this electron. Only electron gun, nickel crystal, this particular scale graduated in degrees. That's all, no? So I'll start moving here. I'll see some deflection. As I move out, when the deflection increases, then somewhere here maximum deflection. Again, the deflection start decreasing here. So why deflection here maximum? Okay, most of the electrons are shaking. Then electron is a particle. Let's go to collision concept. The electron will come collide. Then all electrons will be same mass S. All are having same speed S. Then all should have same angle of deflection. Go back to collision. Straight away ask yourself question. Answer S, we know collision. So let's see that. Let's go back to the collision here. Now a particle of mass m projected with a velocity u. It collide, angle of incidence theta 1, theta 2. Like this, a series of particles will come, one after the other. All particles must have same, all particles are identical, they're having same speed, they're having same velocity and the same angle of incidence. What do you expect? According to the physics, what we know, or what you can say, Newtonian physics, according to Newtonian physics, what we know, all must have same angle of deflection. But here what happened is telling no, such a thing is not happening here. The reason for that, the electron is behaving like a wave. But sir, here, yes, the particular body was behaving like a particle. Not one electron. I think electron beam it is. Direction of incident electron beam. I think if you can understand this, the concept is over. Nothing else big. Rest of everything, some formulas I'll write down. So compare things with it. I'll throw here some 1,000 tennis balls one after the other. All are of same mass. All are made up of same material. All are having same mass, same velocity, angle of incidence. So what do you expect? All must have same angle of deflection, or you can say rebound angle. This is prodded. Then if that is the case, then all the tennis balls will behave like a what? Particle. But here what happened? If this is an electron, if I send like this, so what I see that if the electrons are incident here, if the electron beam, so suppose like 1,000 electrons are incident at a given time. In that 1,000, I see some almost around 600 getting deflected. Then some 30, 40 here, some here, they get spreaded. So what is the reason for that? The electron is not behaving like a particle, it's behaving like a wave. Enough. And how do you can say, sir, how do we can't see electron? I'll just move this galvanometer. I'll note down the deflection. So what do we get? It's the deflection somewhere is maximum. So I'll note down that angle. It's the 50 degrees. Okay, let's see that. How do we can compare this? So the detector, what happened, was showing maximum current. See, science is all about doing experiment, not pen paper. I think that drastically changed nowadays. Not only here, even in nowadays, everywhere what will happen to get into best universities, what happen? The student has to fight with competitive exams, and to get success in competitive exams, what happen? You should practice more numericals. To practice more numericals, what happen? You need more time. Then way to cut the time? Don't do lab, because nobody will ask you any practical question, because the practical questions what happen cannot be twisted. Instead of electron gun, if I throw tennis ball, nobody can ask questions of like that. So I should not be asked also. So when goes for laboratory questions, if I ask you any lab based questions, they'll be straightforward, and any student will get easily rank by attempting that question. So what they have done, competitive exams, they have removed totally the practical question that to be asked, something related to lab. Since lab related questions are not in exam, so we will not prepare. Once you don't do lab, finish or science is highly impossible. Till now, what all you learned is 0.001% because you have not done lab. And even I think after some 6 months, you go to the lab. Within 2 days, how you learn total physics. So you are not in a very comfortable place in science and technology. And that much I can say. So you should give highest priority for this one. But sir, like how to do the lab? Okay, see like a Davissons germer experiment. Yes, can you do in the lab? Yes, provided you should know all these particular things. So at least you can't construct a lab, but some of the things at least you can analyze physically. This is very dangerous. Not only here, so don't. I'm not blaming anything. The same situation is there throughout the world because the number of students, aspirants increase, number of seats are less. So what to do? Conduct exam. So that exams, what happen now, they are killing the thinking ability of a student. So that is the thing. So what will be your future? I think it's a question mark. So until unless you don't bring changes in your approach, even the IITs you go there, they're also same thing. How to assess a student? Okay, conduct exams, semester wise, internal exams like that and all. So again, the moment you conduct exam, finish all. The students will prepare for exam. So again, in the IITs, what happen only you may reach around 0.1% in science and technology. IITs will not help you again big. So you may reach 7. But how much we needed actually, by the time your education completes, at least you should be there around 40% science and technology. So this is showing a lot of impact. So those students again, when they enter into IITs or big, very good universities, okay, that one, along with the academics, what when they focus more on the practical thing, they visit different factories, research labs, they'll analyze the maximum, they give priority. So students will gradually climb up. Only such students are seeing success in the physical world. Remaining on again, what when they'll remain in paper world. This is what happens everywhere in every part of the world. So it's like a now the onus is left on you now. How you build up your career, it's what it's your nobody will help you. Nor IIT is nothing. So it's a you are in a big mess and you can overcome. Nothing is there. Prouded weapon, you should have that vision. Okay, so in the lab, if you just move the galvanometer, you can see the deflection. Only the deflection will tell us that more number of electrons are striking here. Okay, if I plot the current versus the voltage, so let's plot. Let's show some graphs so that at least we'll understand what actually we are studying here. So the graph shows. So the peak is at 54 volt. When the what is that 54 volt? The electron beam should be accelerated, no? And the electron gun weapon, it contains everything. So how to increase the speed of speed of electron by passing through electric field, and there's an expression for this y-axis the current. So detector current. Who is a detector? This is a detector. Okay, this is about the basic current versus this one. So shall we put one thing? So what is this? This shall we write something because this is the incident direction of incident beam, and what is this scattered beam? This will be very troublesome for you. I'll give some rough diagram. This is the incident beam. I think that this will really help you. And what will happen to scattered beam? Scattered beam will be like this. Is it okay now? I'm showing more arrows in this one. The beams will get scattered here. So this is the incident beam. You will take arrows. And this is the scattered beam. At least okay, no? So I think scattered. What is the beam? Electron beam. There's an incident beam. And this is what that angle phi, 50 degrees. Okay, now let me vary the voltage. Then we'll see how do this particular scattering will occur, scattering of electrons will occur. In the electron gun, I can adjust the voltage, potential difference. So how to make the electrons to acquire with a desired speed by adjusting the potential difference. Work done electrostatic field equals change in kinetic energy. So when I plot this same set of graphs for different accelerating voltages, I'll show several some graphs here so that it'll be easy for you. I think, okay, five are enough. Yeah. Let's plot the thing that one. So first 40 volt, I'll take it. What is this arrow? This arrow is a direction of incident beam. In one of the graph, I'll write it. I'll show that there is arrow. Then for voltage, so the electrons, what happen? They'll get scattered like this. This will be the 40 volt. It is 44 volt. 48 volt. Look at that peak. No. So this is the 54 volt. This is what we are doing for in direction of incident electron beam. I think if it is a proton, things will be different here. And this particular angle is what? 50 degrees. And this is 60 volts. So when we can see the peak, when the it's like accelerating voltage is 54 volt and the scattering angle is 50 degrees here. So now we should really justify this what in the lab. In the lab, I got it. So let's compare these theoretical ideas. Theoretically, we'll compare. So we have to do comparison now. So what do you mean by comparison? Theoretically, we'll generate a formula and this is in a lab. So what is the lab? Scattering angle is how much? 50 degrees. And for accelerating potential is 54 volt. Then how to compare this with the theoretical practical? So I'll give this one. So what actually happens here is, why do they get scattered? So inside nickel crystal, what it contains? The molecules. No? And when these electrons, when they go there, the spacing between the molecules will act like a slit, will act like a YDS slit. And then what happens when they go and get collided, they'll get scattered. So the spacing between the molecules of nickel crystal, what happens, will behave like a slit here. So do I know the distance between the molecules in the nickel crystal? Yes, I know. So then I'm going to take help of the formulas, then I'm going to correlate here. So what is the comparisons will be? I'm just taking help of diagrams so that you'll understand what actually you're studying, because in the books just they gave some 1-2 diagram and ended up. So this is scattered beam. And this is the molecule. The incident, just because you know wave, no? So some sort of like the idea of wave is I'm trying to bring. So after collision, it's a rough diagram, just to have an idea that since we know YDS, so to generate that idea is what I'm showing like this. And there's a distance D. What is this? Nickel molecule. No. So I come to, and this is scattering angle. So come for this. So what should be the d sine theta? Should be equal to n lambda. Two d sine theta should be equal to n lambda. I think d sine theta will take it. D sine phi should be equal to n lambda. So what is value of d? Yes, I know it. The phi is what I brought from the lab, and I measure practically the value of d. I know. I know this phi. I substituted here. And n is equal to lambda, put n equal to 1. Just put n equal to 1. So from this, if I measure it, so this d sine theta, I'll end up with 1.65 Armstrongs. Then O is getting scattered, the electrons, no? The electrons only. So let's calculate. And why do they get scattered? Because they behave like a wave. Then what is the matter waves associated with them? Lambda equal to hme into v. So how to calculate this v? So this, I'll do one thing. I'll take help of momentum. What we can write? 2me into k, kinetic energy. Further, how do they acquire this kinetic energy? When I pass through it, I think this E, I'll remove it. Through a potential difference V naught. Don't get confused. V is the speed of electron. V naught is potential difference. PD in electron gun. And what is V? V is the speed. I'll write speed of electrons. All the terms which I assume symbols, I'm putting this one. Speed of electron. So I know what is accelerating potential. What is accelerating potential? I applied 54 volt. When I substitute this here, accelerating potential 54 volt, charge of electron, mass of electron, Planck's constant. No, this is the practical. This is a theoretical. How much I'll get this lambda is? This should be this will be around 1.67 Armstrongs for V naught equal to 54 volt. In the lab, when I measure it, no, I'll get 1.65 Armstrongs. And this should be equal to D, no? No, look at this. Sir, 0.02 degrees. That should happen, no? I think you should never get correct answer. So this shows that as the electrons, in fact, what happened? They're behaving like a wave. Getting the idea? So I just this one. So is it only electron will behave like a wave? No. Now you can take the proton, all different particles. That one. So I'm just giving some good diagrams so that you'll understand what is the thing. So now when they what do these graphs here? This is the incident electron beam. We see that most of the electrons open, they get scattered by an angle 50 degrees. And here when I keep the galvanometer, no, it is showing maximum deflection. When I move like this, it was showing maximum deflection here. So when I calculate that particular angle of 50 degrees here, so that when I substitute here phi, I think that's that phi I'm going to substitute here. And I know the spacing between nickel molecule when I substitute. These are practically, these are theoretically. So this shows that the electrons do behave like a wave, that one. And what is electron? Electron is a matter. So therefore the matter is having like a dual nature. That's what it's saying. Particle as well as a wave. Okay, I think so. I'll wind up this. So these are the some set of diagrams are there. So like this, can we calculate now what should be the accelerating potential, if acceleration potential for different set of like a particles also? They may ask you that one. So here, what should be the acceleration potential so that it should have that much of valence? Means in Davissons germer experiment for electron we did. If I take proton, then mass of proton, then first calculate the lambda involved. So what should be the accelerating potential? Is it okay? In the Davissons germer experiment, this V naught is something very important. So what is V naught? The accelerating potential for which the peak will be noticed here. The peak will be noticed here. So how to calculate that accelerating potential? So here I'll write that V naught. So V naught equal to 54. I think this is not a graph. At least please do understand. I should not call this a graph. What all you are visualizing? No, these are not graphs here. Don't get confused here. These are not a graphs here. So what should be the accelerating potential in the Davissons germer experiment so that the peak can be observed? So that they'll ask you. So first you calculate the lambda associated with that one. With that one you can compare it. So like this in the books they're given for different accelerating potentials where we can see the peak. Okay, I think this is the so now latest, this was the Davissons germer experiment. Now latest what we have IDSC itself. That will be more easy, you know. So you can send even proton beam, electron beam, and you can see that particular the deflection here. Okay, let's go for some numericals. It's there only for mains, huh? It's not there for anything. Only for mains it is there. I'll take the question one. Two identical. All of you got the idea that the matter waves. Just